going to start with questions here in Houston, then we'll go down to the Kennedy Space Center, and then we'll go to the phone lines. We have quite a number of people, so we're asking that you stay with one question, one follow-up, and we'll come back here and go back around one more time. We'll start off with Mark.
Thanks. Mark Carreau for Aviation Week and Space Technology. And I wanted to go back to the software validation work. Could you elaborate some on that? And if I understood correctly, you'll have a follow-on to this FRR on about the 23rd. If you could sort of bridge what happens after that to the launch point.
I can do a piece of it, and then Mike and the others can also chime in. There's still some software work that's going on. Some activities are completing in Hawthorne where they're doing hardware in the loop testing to make sure that the software works right with the hardware. Then when they complete those results, they provide test reports and test analysis of that activity back to the NASA team. And the NASA team looks at that to make sure that it all fits and works the way it was supposed to go work. They'll also do some testing with the actual vehicle down in Florida. Well, they'll do the same kind of thing. Well, they actually run through the software with the flight vehicle. And again, those reports come back to the NASA team. We'll take a look at it. We will not do a formal review like we did today of that activity. What we'll do is we think that'll all be okay, but we'll get a report back from the individual teams, the safety folks, the software folks, et cetera. They'll tell us on the 23rd that everything went as planned. There was no surprises, nothing unique there. And then we'll just continue on then towards the launch. And some of the activities that occur towards the launches, there'll be a flight readiness firing of the engines. There'll be hydrazine loading in the Dragon capsule. A lot of activities occur in kind of that final week. SpaceX also does their own internal flight readiness review, and they'll do that on Sunday, the 22nd, just in front of this review. So that'll be one chance for them to go through to make sure all their individual components and systems are ready to go forward. So I would say today we had enough assurance that everything is moving in the right direction. We're heading towards the 30th. We're not completely there. We want to go ahead and get these final checks from the SpaceX team. After those checks are complete and we understand where they all sit, then we'll say collectively this is the right thing to head forward. So we got enough assurance today that the 30th is the right day to head towards, but we still reserve the right to take a look at the data, see what the software does, and see what the teams find as they go do a more in-depth review.
Eric Berger with the Houston Chronicle. A quick question for Alan, then a follow-up for Elon. First of all, Alan, is it accurate to say that NASA has invested $381 million so far in the commercial cargo capabilities for SpaceX?
Yes, that is the total of the 37 milestone payments we've made to SpaceX to date.
Okay. And then for Elon, you're in Texas today, and it's possible that Dragons could launch from Texas in the future. I'm curious what the state and maybe the federal congressional officials need to do to make this an attractive place for you to build a spaceport.
Well, I don't want us to get too off topic, because I mean, this is really about the upcoming mission to the space station. But we are pretty interested in the possibility of a Texas-based launch site. And I think there's a lot of good action being taken by the local authorities in the Brownsville area in particular. Not that much at the state level. Would certainly appreciate more help at the state level. And then at the federal level, it's not really, I think the federal level is relatively different as to what state we launch from. But we thought it was important to look at having a third launch site just to make sure in the future that if we have a lot of missions taking place for commercial satellite launches, as well as launches to the space station for cargo and potentially crew, and then potentially Defense Department missions, that we didn't encounter a launch site constraint. But I should point out also that we're also looking at potentially using one of the shuttle pads at the Cape for crewed flight. So we just want to make sure that we don't in the future encounter launch site constraints. That's really what we're after with that element. So.
Hi, Kevin Quinn with KTRK ABC 13 here in Houston. And maybe this is a question for Elon. I'm not sure. Maybe it's a NASA question. But can you describe, please, specifically weather restrictions that could affect launch and how those would compare, say, to that which was out there for the shuttle program? Are these tighter restrictions? Or are they lesser restrictions?
I think they're probably comparable. we definitely want to err on the side of caution, particularly since these are initial flights. But I think they're probably comparable. I mean, I'm not entirely certain, but I think similar.
And I think I would say they're pretty compatible. You see it even in our expendable launch vehicles. We have a lot of trigger lightning rules. Those rules will be the same. We have basically the same visibility rules for the ground observers that are watching the rocket fly, those kind of things. So those are all pretty similar. The winds aloft might have been a little more restrictive for shuttle than they are for the Falcon 9. But other than that, I think they're pretty comparable overall.
Jeremy.
Jeremy Diesel from KHOU. Question for Elon. If this is all successful, everything goes exactly as planned,
That would be awesome.
right? What becomes the next step, the next timeline, the possibility of seeing a crewed flight?
Assuming this is successful, then we look forward to a steady stream of cargo flights to the space station under our CRS contract. That would be really super great. And then, because we've designed the spacecraft and rocket to be very similar between crew and cargo, we're in the process. We'll be accumulating a lot of knowledge about how how potential crewed flight might work. And if there is an issue, I think there's a good chance we'd uncover it on a cargo flight rather than potentially put crew at risk, which is, I think, pretty helpful. And then we do have to have a separate contract with NASA for adding in the elements necessary for crew transport. And then there's but there are a bunch of additional steps that have to take place there. But we're optimistic that at some point Dragon will be carrying astronauts. That would be really great.
2 years, 3 years, 5 years, 8 years?
Well, there's a lot of variables between here and there.
Perfect world.
Oh, perfect world? Well, it's probably like 3 years, maybe a little less than 3 years. Yeah. 2.5. Yeah.
Okay. David.
David Hirsch, NHK, for Mr. Suffredini first. Given that the ISS is an international collaboration, I wonder if you could give us a sense of what the importance of the international partnership as far as this entire project and the role of international partners in the FRR today.
Yeah, it's twofold. One is the partnership. The entire partnership does benefit from these vehicles, and in fact, all but our Russian colleagues rely on it. We utilize a suite of vehicles in the futures to provide upmass to ISS and its progress, the JAXA HTV, the ESA ATV, and then the 2 commercial vehicles that we're talking about here today. And the lion's share of the upmass will be provided for the US-OS segment. The lion's share of the upmass will be provided by these commercial vehicles. So it's very important to the partnership. This FR, just like every FR, has all the partner agencies are represented, and so it's important to them. And they worry about not only the fact, will it bring it up, but there are safety implications, there's plume impingement issues, there's EMI, there's all sorts of things that we have to prove to the entire partnership that we meet those requirements. And all of our requirements are meant to protect us from that. And our partners participate in the safety review boards and the analytical process of determining that we're not causing any harm to the rest of the spacecraft. And in fact, part of the responsibility of the U.S. is to ensure the integrated spacecraft is okay. But they would like to see the data, and so we provide the data that's necessary to make them feel comfortable that their element is also safe from those aspects.
Down here. No question? Okay, let's come over here.
Hi, my name is Kensuke Obara from NHK. I hope I can make myself understandable in English, but I would like to ask a question to Mr. Gerstenmaier and Mr. Musk. Everything pretty much seems familiar for a reporter reporting for HTV, and I would really like to ask, what is the connection between this new challenge of SpaceX with the Japanese HTV approach and rendezvous docking? In other words, was there any improvements, or what kind of implications have you had added to this approach for SpaceX? And to Mr. Musk is, I think safety is the priority, but as a commercial company, what kind of aims have you tried to implicate into SpaceX's new launch vehicle, and how would this this new challenge, would, in a sense, add to your overall, I would say, pursuit for that aim, if possible?
Yes, first of all, for your first question, I think we learned a lot from the HTV activities. We did a very similar approach when HTV flew the first time. It flew up and it did a series of gates, very similar to what Holly described in a lot of detail here earlier. So the same kind of approach where we verify a capability before we commit to using that capability, that was done with the HTV, and it was a good chance to see how that process worked, how it worked as a team. I would say also Holly's team and the flight controllers, they got familiar with getting that data from an international partner in the case of JAXA. They took that information, they could then digest it, analyze it, compare it, and work with them. So I think working with the international partners gave us a lot of experience of working with a different community that we don't work with every day, that allowed us to learn how to exchange data back and forth, how to communicate, and how to develop the basic procedure that allows us to learn incrementally, that allows us to get into the berthing box to be picked up with the SSRMS. And I think also that the berthing box concept and using the SSRMS to pick up the Dragon, that's very similar to what we did with HTV. And again, that HTV kind of paved the way of seeing how the crew would use the arm, the overlays they used, the camera ops they use. A lot of that was kind of proven the first time through with the HTV flights that are coming up. So we learned a lot from our international partners, and we applied it to the commercial sector and to Dragon, and it made it a lot easier when we come into this flight. It wasn't the first time around we've seen this stuff, we've seen the basic process and procedure, although the vehicle is very different than the Japanese transfer vehicle.
Right. I think we're grateful for the prior work of the HTV as well, because it made things easier for SpaceX to, approach the space station because of some similarities in the way things are done. So that was quite helpful. The way in which Dragon is most significantly different is that it returns to Earth, rather intact. It's got a heat shield and everything, so you can return cargo to Earth. So that's probably the biggest difference. I touched on this briefly earlier, but because of there's so many similarities between the cargo version of Dragon and the crew version of Dragon, we're learning a great deal about crew transport when we do a cargo mission. I mean, technically, if you've got a little oxygen bottle and you stow it away on Dragon, you, in theory, be okay. You could go to the space station if you're tucked away in there. So it's kind of neat in that respect, and come back too. And then there's sort of a larger context of SpaceX where we want to keep upgrading the technology and making improvements so that ultimately that there can be journeys beyond the space station. So that's obviously a topic for another day, but I think there's a lot of excitement about that, and we're going to keep improving the Dragon technology. So we have an upgrade plan and everything. So, all right.
Okay, I think that's it from here for now. Let's go down to the Kennedy Space Center in Florida and take questions from there.
Hello, this is Marcia Dunn of the Associated Press with a question for Mr. Musk. There's still a fair number of people not totally on board with the commercial side, especially regarding crew transport, and I'm wondering if you feel a lot of pressure as you go into this last 2 weeks before launch to succeed, and how important is it in your mind to launch successfully into berth on this flight?
Well, there's no question that there's going to be some people who will put, I think, too much weight on this flight because it is explicitly a test flight, and indeed we may not succeed in getting all the way to the space station, as I articulated earlier. But I think it would be a mistake to put too much weight on this flight because there are hopefully going to be 2 more flights later this year to the space station, which will be almost identical configuration. So if this one doesn't succeed in getting to the space station, I'm confident that one of the other two will. And we'll work with NASA to resolve any issues and then figure those out and then get to the space station. But there should be no doubt about our resolve that we will get to the space station, whether it's on this mission or on a future one. And I don't think that if this mission doesn't get all the way there, that it should be taken as a verdict on commercial crew transport. I think that just wouldn't be right. Although there will be some people who try to do that.
Thank you. And if this does go well, what is your timeline for those next 2 flights?
Well, that's something we have to work with NASA on. But I think there'll probably be one in the summer and one at the end of the year. But that timing remains to be worked out with NASA.
This is Philip Sloss with NASAspaceflight.com. I believe this is for Ms. Ridings. Can you talk about, for an April 30th launch, when would that red arrow that you talked about on the slide for the racetrack that you're doing, about what time after liftoff, sort of mission off time, would that begin?
Okay, so for an April 30th launch, launch is 11:22 a.m. Central Daylight Time, and you get to right before the red arrow is on the order of 39 hours. So if you were using shuttle nomenclature, which the NASA folks still do, it'd be a flight day 3 fly under. So flight day 1 launch, flight day 2 is really, we call it far field phasing, flight day 3 fly under, so 39 hours. The fly under itself is on the order of 3 or 4 hours, where we're gathering that data. And then if you remember, kind of from the red arrow all the way around, roughly 22 hours. And so you're coming back the next day, really, for a flight day 4 berthing, rendezvous and berthing. So I'll go through it one more time slower. Flight day 1 launch, flight day 2 phasing, flight day 3 fly under, which is May 2nd in our scenario, and then a flight day 4 proximity operation, rendezvous and berthing, so May 3rd. The capture itself, kind of early morning, Central Daylight Time, 7:30. Of course, crew day, that's kind of midday crew day. So the activities will start pretty early in the morning, Houston time, and even earlier in the morning, California time. But the capture would be about 7:30 a.m. In the morning is what it'd be planned for on that May 3rd.
Thanks. And I believe if I understand this correctly, there's the primary opportunities on April 30th, and then there's a secondary opportunity on May 3rd. Can somebody explain why there isn't a daily launch opportunity for this mission, and is this just a mission-specific thing? Thanks.
Yeah. So I'll talk about it a little bit. So some of it is mission specific because of the demonstration. As Elon talked about, this is definitely the demonstration, and so there's a lot more things on this flight. The fly under is one of them. Some of the objectives that we're performing, the analysis that needs to be performed of the data that's gathered on orbit. So the fly under is unique to this demonstration mission, and so that really kind of helps figure out exactly what the launch dates are. The SpaceX team's also reserving some margin that they can talk about, Elon can talk about a little bit, just for contingencies. Again, it's a demonstration, and they want to make sure they've got enough margin if they need it on orbits. We're also always working on the ISS trajectory. So we've got Soyuz flights coming and going. We've got Progress flights coming and going. We've got ATV activities, as was articulated earlier. And so the ISS trajectory is in flux as well. So when you add up all of those different components, you end up with these kind of just smattering of launch dates in the early May timeframe. After the demonstration is complete and we look at all the data, potentially we'll be able to find those back-to-back type things that you were used to with shuttle, but we've got to gather a bunch of data before we could get to the point where we understand that in detail.
Yeah, I mean, I can say in future missions there'll probably be more something closer to daily opportunities. But for this mission, we want to have a really optimal launch. So we're minimizing the propellant usage getting to the space station, and that tends to occur roughly every 3 days. So we just want to have as much propellant available in case something goes wrong and we need to make adjustments to the mission. Yeah, so that's why the 3 days.
Hi, it's James Dean from Florida Today, and just following up on that topic, I wondered if, I understand, I guess, that you have April 30 and May 3 as the first couple of opportunities. Just wondered if you could elaborate any further on if there are any scrubs or anything like that. Are there any blackouts due to the range or the Soyuz launch or any other issues? And so, when did the opportunities fit into the rest of that schedule?
So I can go ahead and take that one as well. So there's actually a little bit of all of those things. There's certainly range conflicts. There are always range conflicts. There are some beta cutouts in terms of the space station. There are some ground rule and constraint type cutouts where we don't want a Soyuz vehicle and the Dragon vehicle exactly on top of each other. We've got to make sure we get one activity completed before we start the next one. The Dragon has some constraints as well for their recovery, where at least for this demonstration, they'd like to land in daylight to help them out with the recovery operations. So there's multiple constraints on the table that we need to line up in order to find an optimized launch window for this demonstration mission. So the answer to your question is kind of all of the above.
Okay, thanks. And then for Elon, this flight, of course, is not unusual for things to slip a little bit, but you were targeting November at one point and then February. And just wondering, what has proven to be most difficult for you to get to the point where you're ready to go? If any aspect of this was a surprise to you at how hard it was. And just as a slightly unrelated question, I was wondering if there are any plans to recover the first stage.
Oh, sure. So, well, I should point out that the rocket is definitely not the constraint. I mean, we could have launched several rockets, Falcon 9 rockets last year if it had just been the rocket. And it obviously wasn't the elements of the Dragon that have been tested before, the Draco thrusters or the heat shield or parachutes or anything like that. The tricky part was really related to the proximity operations and berthing system, so that there's the LiDARs, for example, which is kind of like laser radar, thermal imagers, the communication system, making sure that we can communicate effectively with the space station, with the ground, and with the NASA TDRS system. There's a lot of basically electronics, new electronics on the spacecraft, and it's also the first time we're flying the solar arrays and the radiator system. So those are new elements to the mix. But the thing that really drives the schedule is the software testing, development and testing, and how that interacts with the hardware. That's where the phrase hardware in the loop testing, that's what it refers to, is does the software always do the right thing in a particular circumstance? And when you've got 18 engines and you've got effectively sort of 6 flight computers and a whole bunch of other systems, the test matrix of that is enormous. And a lot of people don't realize that Dragon is autonomous. I mean, it's really, it's a robotic spaceship, and it's going to go and do this complicated maneuver where it's going to berth with the space station. It's not as though there's somebody flying it with a joystick, or that there's somebody on board that can make kind of real-time corrections. Dragon is kind of making lots of decisions all the time to optimize the probability of success. So there's a lot of intelligence on board the spacecraft, and all of that has to be tested thoroughly, and that's the biggest driver of the timeline.
Okay, I think that's it at the Kennedy Space Center. We're going to go to the phone lines now. Let's start off with the Washington Post and Ryan Vastag. Are you there? All right. Let's try Wired Magazine with Jason Parr.
Yes, I don't know if this might be for Holly. Early on, it was talked about some of the work that's being done or the training that was done for the crew on orbit. A lot of that took place on the ground. You said, I'm curious, what sort of preparations are being done while in orbit? I mean, is there any way for them to practice any of the maneuvers? What type of training is done while they're on orbit?
Okay, so the answer is yes, there is the capability for them to practice on orbit. They practice with the actual robotic arm, so the SSRMS. They do some grappling practice, again, sort of line up and pretend that the Dragon is there, and so they know exactly, looking out the window and looking there at their computer screens, what the arm half of that equation is going to look like when the Dragon arrives. They also have a simulator that they practice with because certainly the robotic arm is a significant resource, and so we do have an internal simulator that they can practice, so they can do multiple runs, some very complicated contingencies that we wouldn't want to put our robotic arm in, or that can't be done without the Dragon actually there, some abort type scenarios. So again, they know exactly how to react. So those are their two primary methods of training. They also do some scenarios where they set up all their computers and all their cameras, more the familiarization type training to make sure they have quick reference marks. They can find all the data they need rapidly. And then they do some self-study as well. So again, kind of that building block approach to hardware use all the way to the self-study with the procedures and talking to the folks on the ground.
Up on the whole the demonstration maneuvers and the graphic you showed with the Dragon going from 250 to 220 and then 230, 10 meters. If any of those particular rehearsal maneuvers don't go correct the first time, is there the ability to retry the demonstration, or is it sort of a one-shot attempt?
So the answer is a little bit of both. The demonstrations, some of them occur, you were talking about the ones on the R-bar, some of them occur early in the mission, shortly after Dragon gets on orbit. Those activities will take place. The data will be gathered. It'll be submitted from the SpaceX team to the NASA team. Certainly, if we did not see something that everyone agreed to was acceptable, the SpaceX team might have the capability to retry those as part of their phasing plan. That would be somewhat dependent on the margin they have before they get close to the space station. If we were flying under the space station and were unable to gather the data we needed, it could be done again, but it would require going all the way around and flying under again. But certainly that would be an option if we had enough propellant to do that. And the ones on the R-bar that you mentioned, those, in order to go ahead and complete the berthing that day, need to go pretty quickly. So if they, mostly because sitting again on the R-bar is not a very good place to stay for a long time in terms of your propellant usage. You use a lot of propellant sitting in that area, holding your position underneath the space station at about 250. So if they didn't go well, it would not immediately mean the mission was over, but it would definitely mean you could not continue at that point in time. So it might be that the Dragon would go off and potentially start another fly around, and we would talk about maybe coming back and trying those demonstrations again the next day. So it's absolutely a gate to come on in. If it did not go well, we would look at the consumable resources and work with the Dragon team and see if there was anything we could do to potentially repeat or gather additional data that might help us understand the problem that we'd seen the first time.
Okay. Scott Powers with the Orlando Sentinel.
Actually, I think my question has been resolved, but thank you very much.
Okay.
I appreciate it.
Mike Wall with Space.com.
Oh, yeah, hi. So So yeah, I was interested. Elon talked a little bit about what some of the challenges were from the SpaceX side for this. I'm just curious. What have some of the biggest challenges been on the NASA side, since this is such a new mission for you guys, and you're not responsible for the entire thing from start to finish? What sort of difference has that made for you guys, and sort of what are some of the biggest hurdles to have overcome with this one?
Well, I'll go ahead and answer that one. To begin with, it's just getting used to the idea that we're not worrying about the entire phase of the flight is an adjustment to begin with. Probably the biggest difference once you settle on that aspect of it, probably the biggest difference is we're verifying a system based on requirements we gave for performance, but in terms of developing the hardware, the design of the hardware, how individual boxes are laid out, the design concept, the components that were used, that's not the kind of information we have access to. And so it's been kind of an adjustment for our engineers to create requirements and validation steps that give you confidence in the robust nature of the design that's being flown. And so that was probably the biggest adjustment that we made. It's been, as I mentioned earlier, it's been really kind of a fascinating process, because you begin with this group of engineers that have been doing this business for many years, who have gotten information passed on from the engineers before them that have done this job a certain way, with a complete push towards safety and mission success, because each flight was so very expensive that while safety was critical, mission success was very important. And everything from the procurement of EEE parts all the way up to the integrated performance testing of a system, and how you're going to put it together and how it's going to react to anomalies, all that was something that you spent many years in your mind perfecting. And then to go sit with another company and say, this is your requirement, and then have that group of very clever engineers, many of whom maybe don't know that much about space, many of them who did, but all of them very young, have them say, well, why? And instead of the NASA engineer being able to say, well, this is how we did it, the question was, why do you do it that way? And so when that exchange took place, it was quite enlightening experience for us both, because once it was clear to the SpaceX engineer what it is that the NASA engineer was perfecting it, trying to protect against, then the light bulbs would come on and go, oh, okay, well, in order to solve that issue, this is how I do it with my design. And then the NASA guys would learn from that. And so the biggest piece of it, I think, from my perspective, and it's not a bad thing, it's just an adjustment, and I think actually it's been good for both sides, is that we've learned, or we kind of had our eyes opened up to different ways of tackling similar problems, and in that respect, it's been very beneficial. But I would tell you that it's an adjustment not to have the very detailed design data that we're used to when you actually design the hardware, and we're more looking at it from a performance standpoint.
And I would add one thing too, a little bit, is that the space station team got to see a piece of this as we put modules on board space station. Again, the international partners built to a set of our requirements, but they accommodated those requirements in a potentially different way than we did. So in a non-maneuvering vehicle kind of standpoint, the station team got a chance to see how to work with a set of with a partner that essentially answers the how to our requirements. And Mike's discussion was very good about how both teams have really learned from each other. I get a chance to kind of sit back and watch both teams learn from each other, and it's been a tremendous learning experience for both of us. I think we've learned new things on the NASA side, some things we've always done a certain way, and then when we get asked now, why do you really do that requirement, it's really forced our folks to go think about it, and we're starting to kind of internalize it. Hey, there may be another way of doing some things that are better. So we've definitely learned some things from SpaceX, and hopefully I think they've learned some things from us as we go through. So as a good partnership, you learn from each other, and you end up with a much better product coming out the other side.
Okay, how about Michael with Popular Mechanics?
Hi, I wonder if someone could break down more specifically what's cargo is going to be on the flight? What sorts of hardware? And also, are there going to be any crew provisions on there too?
Well, in fact, primarily it is crew provisions. We're flying quite a bit of food. Crew provisions, some replacement consumable type components. We have one Nanorex payload that's got some, it has a number of student experiments on it. That's the lion's share of it. A lot of it is food, but the majority of it is actually food and crew provisions.
What's the total weight again, going up and then coming down again?
521 kilograms of cargo up and 660 kilograms down. And the down manifest is not completely finalized. One of the things that happens once you get to orbit is you sort of agree on the mass down and the biggest drivers of that mass, knowing that once you get there you might change that a bit. But as I mentioned earlier, we do have some, while we kept away from putting one-of-a-kind orbit replacement units or major components on the ascent side, we actually did put some ORUs on the return side in hopes of getting them home so we could refurbish them. They're not required, but in a couple of cases, if we can get them home and refurbish them, it'll save us money, because otherwise we would have had to procure that spare. That's certainly in our plan, and our budget is to procure the spare, but this was a chance to try to get some home and save some money. So we actually do have some ORUs coming home on the down manifest.
What are ORUs?
Those are the replacement spare components to replace components on board. We have a pump, a couple of multi-filtration beds that were in the water processor, and our JAXA colleagues have a power supply box for their communication system on orbit that's also coming home.
Great, thanks a lot.
Okay, Lisa Grossman with New Scientist. Lisa? Okay, Jason Davis with Planetary Society.
Hi guys. You had talked about some of the gates and specific checkpoints that the Dragon would be required to go through during each stage of the approach. And I just wanted to know who holds the final authority to make decisions during a contingency. Has that already been planned out in advance, or are there situations where a single party, either NASA or SpaceX, would have to make a decision on how to proceed? Thanks.
And I'll take that one. So it certainly depends on where you are in the mission. If it's very early in the flight and the launch and that far field phasing where the Dragon is not near the space station, then it's the responsibility of the Dragon team and SpaceX. But once the Dragon arrives near the space station, and near is kind of defined by my graphic, it's coming up about 10 kilometers below the space station, then there are, and actually during the fly around, there are go, no-go points. Again, I defined that earlier as we take a poll and make sure we've got all the capabilities. And all of those go, no-go points, the team here in Houston, per our documentation, holds the final authority. There's also a couple other cases if we do have an abort, something that is unexpected, that the Dragon needs to leave the proximity of the space station, and then the Dragon team can figure out that issue and put the Dragon back on a trajectory to potentially make another attempt. That process, Houston has authority over that process. And then if anything were to go really unexpectedly wrong with the space station, even if the Dragon is fairly far away from us, we would exert some authority in the sense of telling them we're absolutely not going to be ready for you anytime soon, so we don't want you to come up too close to us. And so there's kind of the very specific predefined items, again, those go, no-goes that are in our flight rule, that are those height adjust, again, the burns, the maneuvers the Dragon performs as it comes increasingly closer to the space station. There are those points predefined as it flies around the space station, and those points predefined as it comes up to do the final rendezvous and the berthing and the proximity operations. And then there's those generic catch-alls for if something goes unexpected, and all of that has been discussed with the team in Hawthorne and our team here in Houston, and is all written down in our documentation that we fly with, our flight rules.
Okay. Jean-Louis Santini from Agence France. How about Kelly Sheraton? Okay. Eric with Nature Magazine. I'll keep going. Stephen Clark with Spaceflight Now. Maybe they got tired of the music. Ann Walters with the German Press Agency. How about Irene Klotz?
Thanks, Josh. I am here. I have a couple questions for Elon. The first is, including that $381 million from NASA, how much more money has SpaceX spent to get to this point in the development? And overall, what do you think the odds are that this mission will be completely successful in terms of docking at station and a successful retrieval after splashdown?
I don't have the exact number that SpaceX has spent, but we have raised several $100 million in venture capital, the initial part of which came from me, and then there's been ongoing payments for other milestones that have been achieved for NASA and for other customers. I think probably the total amount spent cumulatively would be somewhere around $1 billion. So that's cumulative over the life of SpaceX. And then in terms of the probability of success, I have some hesitation about giving an exact number, since they're pretty big. There's a pretty big range, I think. But yeah, I perhaps I'll hesitate to give an exact number. But I mean, I think that the likelihood that the rocket works is pretty good, since it's worked twice before. Likelihood of the spacecraft, the non-berthing, or portions of the spacecraft that have been flown before working, is also quite good. But then there's much more of a question mark around the proximity operations and berthing system and the solar arrays, which are being tested for the first time.
For either Bill or Alan, could you just refresh my memory and tell me what it would cost approximately, based on, I think GAO did a report, if NASA had developed a similar capability under a traditional cost-plus award fee contract?
Well, there were studies done that said if you use our traditional modeling and our traditional approaches and assumptions, it could have been anywhere from 4 to 10 times higher under a traditional NASA development.
Thanks very much. Good luck.
Okay, thanks, Irene. Is there anybody else on the phone line that did not get a chance yet or would like to ask a follow-up?
Hey, Josh. Bill Harwood with CBS.
Hey, Bill. Go ahead.
Oh, thanks a lot. Two quick ones for Holly. If the Atlas stays on the range where it is, and if Soyuz stays where it is, which they will, and if SpaceX doesn't get off in those first 2 attempts, when would this guy slip? How far would it slip? I'm assuming after Soyuz, and it wouldn't be a way to get it in between Atlas and Soyuz. Is that right?
Yeah, so I mentioned earlier there's quite a few variables. In general, yeah, there's a window kind of this late April, early May, which is when we've been talking about with the 30th and the 3rd, and potentially some options. I know the Atlas is in there. And then there's an after Soyuz window kind of in the mid to late May time frame. And mentioned earlier, a lot of the variables and all of those need to line up, but those are the 2 windows that are the high probability ones that we've been looking at right now.
All right, and one more quick one for you, and this will do it for me, Josh. Can you give us a little bit better sense of what sort of issues you guys have been working on the last couple of months with SpaceX? I mean, obviously they wanted to launch in February, and it slipped a bit, and I've never heard any good details about what sort of things everybody was trying to get resolved that took the extra time. If you could give me some sense of that, I'd appreciate it. Thanks.
Okay, well, I can certainly tell you from an operational perspective, a lot of the capabilities that the SpaceX team wanted to work on were their mission success capabilities, things that Elon can probably tell you are very important to them. So when they came with those capabilities, that obviously requires a joint sort of review and determination. One of the ones we talked a lot about was recovering from abort type scenarios. Those capabilities are complicated and difficult, and we'd done some preliminary work, but we really took this extra time to make sure that we've got a real solid plan so that we've got a higher probability of being able to work together to accomplish their primary objective, which of course is the success of the mission. And so we made our teams here, the operations team as well as other teams, available to really talk through some of those items. That's my example, and I don't know, Elon, if you have others. That's really the one we've spent probably the most time on in the operations world talking about, because it's very important. We want to be able to do that as a team in the event that we need that capability.
Yeah, I think it's like I said earlier. It's really just about the hardware loop testing and validation of the software. That's the biggest driver. I mean, there were other things that were done in that time, but just testing a vast amount of intelligence that's occurring in the software, and making sure even in highly unusual situations that the mission is successful, at least in the simulation. That's what's taken the most amount of time, and it's just a very, very complex system.
Okay. Thanks, Bill. Is there anybody else on the phone lines? All right, let's come back here to Houston. Let's start back over here with Mark.
Thank you, Mark Carreau, for Aviation Week. I guess I'm a little hazy on whether there's an MMT authority during the flight, or if that is the space station, IMMT, that sort of is the big picture supervision.
It's the space station IMMT.
Thank you.
Eric Berger again with the Chronicle. A quick question for Bill or Mike. Could one of you address the feeling inside the space program with this launch coming up? Because this is an American company, and obviously there's been a lot of heat on NASA in the last couple of years relying on Russian rockets for humans, and this is a potential way out of that. Is it something that a lot of people are looking forward to, or how would you characterize the mood sort of leading up to the launch?
You want to do mood, or do I do mood?
You can do mood.
Thanks. Well, from our perspective, what you're referring to is probably a combination of perceived emotions way back when we started down this road, because it had to do with getting out of the space shuttle business and getting into a commercial venture, and that probably played a little bit of the role of a misconception and perhaps not everybody being completely behind this effort. But I can tell you from a program perspective, and those are the people that I see and talk to every day, we couldn't be more pleased with what we're off to go do. And the reason is, it provides indigenous capability within the U.S. to supply the ISS, which we think is very important. It does have implications to human transport, again, to ISS. It's commercializing, if you will, helping commercialize a low Earth orbit, which we think is a very important need and something that NASA is responsible for. And some of us, and in particular myself, believe this is a very important step for us to take in order for us to do exploration in the future. NASA needs to develop or encourage a capability and help the development of a capability, of a commercial capability to support low Earth orbit, both in terms of cargo and humans and other capabilities, robotic servicing, things like that. And NASA needs to start focusing on human exploration beyond low Earth orbit. And so those of us who are looking forward to the next step for NASA really are very excited about this next step for the space station. And we believe this is in order for space station to be successful, these systems have to be there for us, and so we look on it very favorably and are very excited about this pending launch.
I think I'd add just a little bit. This is absolutely critical to space station. We really need this cargo capability to be able to get to station, and the return capability that Dragon provides is truly unique of any one of the cargo providers, including the Russians and Soyuz. The amount of cargo we can get back with Dragon is just phenomenal from a return standpoint. So we absolutely need this capability for ISS, and we're really rooting for the teams to come through. I think it's also been encouraging to see SpaceX to work hard issues. They had some EMI, electromagnetic interference issues that they worked, and they spent some really good engineering time to resolve those issues and get them resolved. They had some engine delamination concerns, and again, they were very rigorous. They tested some things that maybe you didn't absolutely have to go test, but they wanted to go test them to make sure that they were right. That's really encouraging. So I can really, get behind somebody that's doing that extra work to get ready to go fly. But as Elon said, this is really a tough flight. I mean, what we're asking them to go do on this demonstration flight is amazing. When you look at all those things that Holly talked about on her charts and the many hours that all this hardware has to work and all the software has to interact, and the 6 computers and the 18 thrusters and all this has to work as a nice combined set to get into this precise box to be picked up by the SSRMS, that is no easy task. So this will be a very demanding mission, and we need to look at it as a test flight. It's what it should be. We'll see how well the test works out, but they've really done a good job in getting ready for this test. So as a NASA team, we're ready to watch, participate, and help, and we truly need this capability for ISS.
David?
Yeah. And just to get a more detailed sense of where we are technically today as of this meeting, the hardware in the loop issue that you were describing a little bit earlier, does that relate specifically to something on the timeline that Ms. Ridings was taking us through earlier, a specific element there, or is that, as you're saying, maybe something that's more generalized over the entire mission?
Yeah, so hardware in loop means, just to give you a little more color on that, essentially we have a complete replication of the Dragon's avionics system on a bench, and then it flies a simulated mission, and it actually, it's like a sort of like a brain in a tub thing. It actually thinks it flew to the space station, and it does. And we watch to see what it does. Does it do all the right things on the way to get there? And if it doesn't, then where did it go wrong? And what happens if we unplug certain devices, essentially simulating failure at the worst possible moment? Does it then take the proper steps? And then what happens if you fail several simultaneous things? And what if you fail something and then restore it? There are many, the cross product of all those things is a huge number of tests. So there's just.
You're introducing failures.
We introduce failures, yeah.
So there's nothing along that timeline, just to move it along, because I know it's getting late here, that in Ms. Riding's timeline that you're specifically focused in as far as a mission element that might be problematic. You just need to introduce more failures and troubleshoot that and see how the system's going to react.
Right, exactly. In fact, the recent, say in the last month or so, the tougher things have been to deal with false aborts, where it actually initiates a mission abort because it was too sensitive to the parameters. So things were actually okay, but Dragon got too worried and aborted the mission. So
from LA, so
right. So it's you don't want to have. It definitely needs to abort if something's wrong, but sometimes it may think something's wrong, but it's actually okay. And there are all sorts and there are all different types of failure. Like I said, you can have something fail and stay off. You can have something fail erratically, where it goes off and comes back, and sort of oscillates. You can have multiple things fail at the same time, and the system has to be able to deal with all of those contingencies.
Okay, is that it here in Houston? Okay, before we finish up, we're going to take a look at our launch and mission coverage that we have upcoming here on NASA television. Coming up at L-1, there will actually be a pre-launch news conference from the Kennedy Space Center. And then on Monday, April 30th, at 10 a.m. Central Time, that is when our launch coverage will begin. And once again, launch actually scheduled for 11:22 a.m. Central Time right now. And then at 1 p.m. Central Time, we'll have a post-launch news conference from KSC as well. On Flight Day 2, which right now should be Tuesday, May 1st, we will not have any live coverage here on NASA television, but we will have an update during our typical daily ISS update show here at JSC, which will air at 10 a.m. Central Time, 11 a.m. Eastern. And then on Wednesday, May 2nd at 1:30 a.m. Central Time, very early in the morning, we'll have our fly under coverage from here at the Johnson Space Center inside Mission Control Houston. And at 9 a.m. Central Time, we will have a mission status briefing here at JSC as well. And then finally, Thursday, May 3rd at 1 a.m. Central Time, that is when our rendezvous and berthing coverage will begin here at the Johnson Space Center, once again from Mission Control Houston. And then at noon Central Time, we should have a mission status briefing again here at JSC. Of course, all these times are subject to change. To see all of this and to also see any of the slides that you saw today from our participants, just log on to www.nasa.gov/SpaceX, all lowercase. It's important that you do that. If you look on the right-hand side of the page down at the bottom, there's a media resources section. You can find all these slides as well as the press kit once we get it finished up and posted there, as well as the NASA TV schedule. So just log on to there to get all of the latest. I want to thank all of our participants for joining us today, and we'll see you back here in a couple of weeks for the SpaceX mission. Thank you.